How? Impossible. Browning M1919 tweak transformed U.S. defense at El Alamein versus MG42s and tanks. The scorching sun beat down relentlessly on the North African desert, a vast, unforgiving expanse where the fate of nations was being forged in fire and sand. Here, the roar of tank engines, the staccato bark of machine guns, and the desperate cries of men echoed across the dunes. It was a theater of war defined by brutal efficiency, where the German Afrika Korps, under the cunning leadership of Field Marshal Erwin Rommel, had carved a fearsome reputation. Their panzer divisions, a steel tide, swept across the landscape, supported by infantry armed with what many considered the finest general-purpose machine gun of its era, the MG42. This weapon, a marvel of German engineering, could unleash a torrent of lead at an astounding rate, often exceeding 1,200 rounds per minute, tearing through Allied lines with devastating efficacy. Its distinctive, high-pitched sound struck fear into the hearts of soldiers, signifying an unstoppable wave of suppressive fire that pinned down infantry and allowed tanks to advance almost unmolested. Against this formidable adversary, Allied forces, including the burgeoning American presence, often found themselves outgunned and outmaneuvered. While the Allies possessed their own reliable workhorses, none faced the German threat with the same raw, terrifying efficiency. Among the most ubiquitous American machine guns was the Browning M1919, a venerable design that had proven its worth in countless engagements. Rugged, dependable, and relatively easy to maintain, the M1919A4, the most common variant, was the backbone of Allied infantry fire support. It was an air-cooled, bell-fed medium machine gun, firing the potent .30-06 Springfield cartridge. Its rate of fire, typically around 400 to 600 rounds per minute, was respectable, and its accuracy was commendable. It was a weapon that soldiers trusted with their lives, a steadfast companion in the chaos of battle. However, trust and reliability, while crucial, were not always enough. In the face of the MG42's blistering rate of fire and the seemingly impervious armor of German Panzer IVs and Tigers, the M1919, for all its virtues, began to show its limitations. Its air-cooled barrel, while simpler than water-cooled systems, meant that prolonged bursts of fire would quickly lead to overheating, necessitating frequent barrel changes or a reduction in fire volume. This critical flaw was brutally exposed when attempting to suppress dug and MG42 positions or provide continuous covering fire against an advancing German assault. The M1919 simply couldn't keep pace, its sustained output lagging far behind the German buzzsaw. Moreover, while its .30-06 rounds were effective against infantry and light vehicles, they were largely impotent against the frontal armor of enemy tanks. Soldiers often felt a profound sense of frustration, watching enemy armor roll forward, knowing their M1919s could do little more than peck impotently at the steel behemoths. The M1919 was a defensive weapon, excellent for holding ground, but it lacked the offensive punch or the sustained suppressive power needed to truly dominate the battlefield against a technologically superior foe. The strategic landscape of North Africa demanded a change, a revolutionary leap in capability that could turn the tide. Allied commanders recognized the urgent need for a weapon that could not only match, but surpass, the German MG42 in sustained fire and offer some form of credible deterrence, however limited, against enemy armor. The pressure mounted on ordnance departments and weapons designers. Could the existing M1919, a design dating back to World War I, be fundamentally altered to meet these new, extreme demands? Many believed it was an impossible task. The M1919's design was mature, optimized for its intended role. To drastically increase its rate of fire, improve its cooling, and somehow give it an anti-tank capability, all while maintaining its reliability and field serviceability seemed like a fantasy. It would require a complete re-engineering, a new weapon altogether, not merely a modification. The prevailing wisdom dictated that one simply did not try to turn a reliable medium machine gun into a heavy machine gun or an anti-tank weapon. The inherent physics of the .30-06 round and the air-cooled mechanism presented seemingly insurmountable barriers. Yet, in the crucible of war, impossible ideas sometimes found fertile ground. In a nondescript, heavily guarded research facility tucked away in the American heartland, a small team of engineers, driven by a blend of desperation and audacious ingenuity, began to challenge these long-held assumptions. Leading this clandestine effort was Dr. Alastair Finch, a brilliant but notoriously eccentric ballistics engineer with a penchant for unconventional solutions. Finch, a man who preferred the solitude of his workshop to the bureaucratic halls of the Pentagon, had spent years dissecting the performance metrics of every machine gun known to man. He saw not just the M1919's limitations, but its hidden potential, its underlying robustness waiting to be unleashed. He believed that the very simplicity of its design offered avenues for radical enhancement, rather than hindering it. His initial proposals were met with incredulity, even outright derision. "You want to make a .30 cal machine gun fight tanks?" senior officers had scoffed. "And outshoot an MG42 without melting its barrel? Finch, you're dreaming." But Finch was not easily deterred. He argued that the M1919's fundamental action, a short recoil operation, was inherently stable and could handle substantially greater stresses if properly managed. His vision was not to create an entirely new weapon, but to transform the M1919 into something far beyond its original design parameters, a true multi-role asset capable of punching above its weight. The core of Finch's impossible tweak revolved around three interconnected pillars: a revolutionary cooling system, a specialized ammunition variant, and a refined firing mechanism. The first, and perhaps most audacious, modification was a radical overhaul of the M1919's air cooling apparatus. Finch and his team devised an intricate, lightweight, and surprisingly robust forced air cooling shroud system. This wasn't merely an enlarged barrel jacket. It incorporated a series of precisely angled internal baffles and external vents designed to create a venturi effect, drawing in cool air at an unprecedented rate and expelling superheated air with remarkable efficiency. Furthermore, a miniaturized, high-speed, electrically driven fan, powered by a compact, detachable battery pack or a simple hand crank generator for emergency use, was integrated into the shroud. This fan, small enough to not significantly impede the weapon's profile, could be activated during sustained fire, actively pulling air across the barrel and breech block, dramatically reducing heat buildup. This innovation, considered heretical by traditionalists who valued simplicity above all else, promised to allow the M1919 to sustain bursts of fire previously unimaginable for an air-cooled weapon, potentially matching the suppressive capabilities of the MG42 for extended periods, without the need for frequent barrel changes. The technical challenge lay in miniaturizing the fan and battery, ensuring their resilience in harsh combat environments, and integrating them seamlessly into the existing weapon structure without adding excessive weight or complexity to field maintenance. Early prototypes of this cooling system were prone to fan motor failures and battery drain, but Finch's team persevered, experimenting with new alloys and power management systems. The second pillar of Finch's transformation addressed the M1919's perceived impotence against armor. While acknowledging that a .30-06 round could never penetrate the thickest frontal armor of a heavy tank, Finch believed it could, with the right ammunition and delivery system, become a significant threat to lighter armored vehicles, exposed tank components, and, crucially, the morale of tank crews. His team developed an advanced tungsten cord armor-piercing incendiary (API)
round for the .30-06 cartridge. This wasn't merely a standard API round. It featured a specially designed, hardened tungsten penetrator encased in a copper jacket, with a small incendiary charge in the nose. The projectile's aerodynamics were also subtly improved to enhance accuracy and velocity at longer ranges. While still unable to punch through a Panzer IV's glassy plate, these new rounds were engineered to reliably penetrate lighter armored vehicles, such as half-tracks and armored cars, and, more importantly, to disable critical external components on tanks. A concentrated burst, delivered with the enhanced accuracy and sustained fire of the modified M1919, could disable tank optics, destroy external fuel drums, damage track links at close range, or even ignite ammunition stored externally. The incendiary component added a psychological dimension, creating blinding flashes and smoke, potentially forcing tank crews to button up or even abandon their vehicles under relentless assault. The challenge was in perfecting the manufacturing process for these complex rounds, ensuring consistent quality and mass production capability. Finally, the firing mechanism itself received a subtle but critical refinement. Finch's team developed an adjustable gas-operated accelerator system that could slightly increase the weapon's cyclic rate of fire. This wasn't about pushing the M1919 to the MG42's extreme, but rather allowing for a controllable increase from 400 to 600 revolutions per minute to a more robust 700 to 800 revolutions per minute when needed. This adjustable system meant that a gunner could switch between a lower, more controlled rate for precision fire and a higher, more suppressive rate for engaging multiple targets or laying down a wall of lead. This was achieved by a clever modification to the recoil spring and a redesigned bolt assembly, which, when combined with the superior cooling, allowed for longer, more effective bursts. Furthermore, a new, more stable tripod mounting system was designed. This new mount incorporated a sophisticated dampening system and quick adjustment mechanisms, allowing for faster target acquisition and significantly improved accuracy, especially when firing the new API rounds against moving or distant targets. The combination of sustained fire, specialized ammunition, and improved accuracy was designed to transform the M1919 from a static defensive weapon into a dynamic, versatile instrument of both suppression and limited anti-armor engagement. The path to realization was fraught with setbacks. Early prototypes of the forced air cooling system often seized up in the fine desert dust, and the initial tungsten-cored rounds sometimes fragmented prematurely upon impact. Bureaucracy and skepticism were constant adversaries. Senior ordnance officers, steeped in traditional doctrine, viewed Finch's project with suspicion, labeling it an extravagant waste of resources. Why tinker with a proven design when we could be developing entirely new weapons? They argued. But Finch, fueled by a deep conviction in his vision and the grim reports from the North African front, pushed relentlessly forward. He conducted clandestine field tests, often under the cover of darkness, pushing the prototypes to their absolute breaking point. Barrels glowed cherry red, ammunition belts ran dry, and cooling fans whirred until they screamed, but slowly, painstakingly, the design flaws were identified and rectified. New materials were sourced, manufacturing processes refined, and the engineers worked around the clock, driven by the urgency of the war. They knew that if this impossible tweak could be perfected, it wouldn't just be an incremental improvement, it would be a fundamental shift in the capabilities of the common infantryman, providing a vital edge against the formidable German war machine. The first successful full-scale deployment of the modified M1919, now unofficially dubbed the Scorpion, by the testing teams due to its venomous bite and unexpected lethality, occurred during a simulated assault against captured German armor and infantry positions. The results were nothing short of astonishing. A single Scorpion, manned by a highly trained gun crew, was able to lay down sustained suppressive fire for minutes on end, its barrel remaining within operational temperatures, a feat previously thought impossible for an air-cooled machine gun. The devastating torrent of the new API rounds, delivered with unprecedented accuracy, scarred the dummy tanks, peppering their optics and external components with deep gouges and small, localized fires. The psychological impact on the observer teams, who had previously dismissed the M1919 as a secondary threat to armor, was palpable. They watched as the Scorpion tore into a mock half-track, riddling it with holes and igniting its fuel tank within seconds. It wasn't an anti-tank gun, no, but it was a weapon that could undeniably harass, disable, and terrorize enemy vehicles in a way the standard M1919 never could. It was a weapon that could force tank crews to make mistakes, to expose themselves, to become vulnerable to accompanying anti-tank assets. Against simulated MG42 positions, the Scorpion demonstrated its ability to maintain a sustained volume of fire that effectively suppressed and neutralized mock enemy gun crews, often outlasting the simulated MG42s in continuous engagement. The tide of skepticism began to recede, replaced by a cautious, then fervent, optimism. The impossible was slowly, painstakingly, becoming reality. The strategic implications of the Scorpion were immense. It represented not just a technological upgrade, but a paradigm shift in infantry tactics. No longer would the M1919 be relegated to a purely defensive role, a weapon to hold the line until anti-tank guns arrived. With the Scorpion, infantry units could now possess an organic, highly mobile asset capable of both sustained suppressive fire against superior enemy machine guns and a credible, if limited, offensive capability against lighter armored vehicles and the vulnerable external components of tanks. It meant that a well-placed Scorpion team could potentially disrupt a panzer advance, forcing tanks to button up, lose situational awareness, or even abandon their advance due to critical damage to optics or tracks. It could create crucial windows of opportunity for anti-tank teams to close in or for flanking maneuvers to develop. It was a force multiplier, giving the common soldier a fighting chance against threats that previously seemed insurmountable. The transformation was not just in the weapon itself, but in the confidence it instilled, the tactical flexibility it offered, and the psychological blow it could inflict on an enemy accustomed to their overwhelming technological superiority. The news, carefully filtered through intelligence channels, began to circulate among Allied high command. A new breed of M1919 was emerging from American workshops, a weapon designed to meet the German challenge head-on. The urgency to get this transformed machine gun into the hands of fighting men, particularly those facing the brutal realities of the North African campaign, became paramount. The logistical hurdles were monumental, the scale of production daunting, but the potential reward, a decisive edge on the battlefield, was too great to ignore. The stage was set for the Scorpion to prove its worth in the unforgiving crucible of combat, to write a new chapter in the annals of mechanical warfare, and perhaps to transform the very nature of Allied defense against the formidable might of the Afrika Korps and their devastating MG42s and tanks. The logistical challenge of deploying the Scorpion M1919s to the North African front was a monumental undertaking, shrouded in the utmost secrecy. Each modified weapon, along with its specialized ammunition and cooling system components, was meticulously crated and transported under heavy guard. Dr. Finch, now an almost mythical figure among the Ordnance Department's inner circle, personally oversaw the first shipments, his gaunt face etched with a mixture of exhaustion and fierce determination. The journey across the Atlantic, fraught with a constant threat of U-boat attacks, was a nerve-wracking ordeal. Once ashore in Egypt, the crates were rushed through desert roads, their contents unknown to most, even the soldiers guarding them. The destination was a series of provisional training camps, tucked away from prying eyes, where a select group of American and British machine gunners would be introduced to their new, formidable weapon. Initial reactions from the seasoned infantrymen were a blend of skepticism and weary curiosity. These were men who had faced the MG42's terrifying roar and the relentless advance of Panzer IVs countless times. They knew the M1919 intimately, its strengths and, more painfully, its glaring weaknesses. When presented with the Scorpion, a standard-looking M1919, but with an oddly proportioned cooling shroud and an unfamiliar battery pack, many grumbled.
"Another fancy gadget that'll break down in the sand,"
one grizzled sergeant muttered, echoing the sentiments of many. Dr. Finch, who had insisted on being present for these initial introductions, faced a wall of hardened pragmatism. He patiently explained the modifications, the forced air cooling, the adjustable rate of fire, and the new tungsten cord API rounds. He demonstrated the weapon's sustained firing capability, letting a prototype chew through hundreds of rounds without a hint of overheating, a sight that slowly began to chip away at the cynicism. The real skepticism, however, lay in its anti-armor claims.
"You're telling me this .30 cal will bother a Panzer?"
A corporal scoffed, incredulous. It was a fair question, and Finch knew only combat could answer it definitively. Training was intensive and rigorous. Gunners had to learn not just to operate the weapon, but to understand its new nuances. The maintenance of the forced air cooling system, particularly keeping the fan mechanism free of the ubiquitous desert dust, was paramount. The battery packs, while robust, required careful management and recharging, a new logistical burden for units accustomed to purely mechanical systems. The adjustable rate of fire, while offering tactical flexibility, demanded discipline to avoid squandering precious ammunition. But it was the API rounds that truly changed the game. Instructors hammered home the concept. The Scorpion was not an anti-tank gun, but an anti-tank harasser. Its role was to blind, disable, and demoralize, to create opportunities for dedicated anti-tank teams or to force enemy armor into vulnerable positions. Targeting tank optics, track links, external fuel drums, and exposed crew members became the focus of countless drills. Slowly, a new understanding began to dawn on the crews. This wasn't just an M1919. It was a tool designed to fight smarter, to exploit vulnerabilities, and to give them a fighting chance against seemingly invincible foes. The first true test of the Scorpion came during the brutal opening phases of the Second Battle of El Alamein. The desert was a maelstrom of steel and fire, with Rommel's Afrika Korps launching desperate counterattacks against the Allied lines. In one particularly savage engagement, a company of American infantry found itself pinned down by a tenacious German MG42 position, supported by a menacing Panzer IV that was slowly advancing, its turret traversing menacingly. Private Miller, a young but resolute machine gunner, was part of a Scorpion team holding a critical crossroads. His standard M1919 had already overheated, its barrel glowing faintly, forcing him to pull back. Now, with the Scorpion in hand, he felt a surge of nervous energy. The MG42, hidden in a well-camouflaged dugout, chattered relentlessly, its high-pitched buzz sawing through the air, keeping Miller's comrades pinned.
"All right, Miller, let's see what this fancy fan can do,"
Sergeant Davies yelled over the din of battle. Miller nodded, his hands sweating on the grips. He sighted down the weapon, adjusting for the distance. The MG42's muzzle flash flickered rhythmically. Taking a deep breath, he squeezed the trigger, engaging the forced air cooling fan and setting the rate of fire to its higher setting. The Scorpion roared to life, a deep, resonant bark that quickly settled into a sustained, heavy thrum. Unlike his previous M1919, which would have sputtered and overheated, the Scorpion poured out a continuous stream of .30-06 rounds. The distinctive sound of the MG42 faltered, then resumed, but with less confidence. Miller shifted his aim, sweeping the area around the German position, laying down a wall of lead that forced the enemy gunners to keep their heads down. He kept firing, the cooling fan whirring audibly, drawing away the intense heat. Minutes stretched into an eternity, but the Scorpion held its sustained rate, its barrel remarkably cool to the touch compared to what Miller was used to. The German MG42, unable to maintain its own blistering rate under such relentless suppression, finally fell silent. A small cheer went up from the pinned American infantry. But the Panzer IV was still advancing, its 75mm gun a terrifying threat. It traversed its turret, searching for targets. Miller knew he couldn't stop it, but he could harass it. Switching to the API rounds, he focused on the tank's optics. The tungsten cord projectiles, delivered with the Scorpion's newfound accuracy, began to pepper the Panzer. Sparks flew as rounds ricocheted off the thick armor, but Miller aimed for the commander's cupola and the driver's vision port. A concentrated burst slammed into the periscopes, shattering the glass and sending shards flying. Another burst impacted the track links, causing a sickening clang. The tank, momentarily blinded and feeling the relentless impacts, hesitated. Its advance slowed, then stopped. Crucially, the incendiary component of the API rounds created small, bright flashes and puffs of smoke on impact, visually disorienting the crew and adding a psychological dimension to the assault. The German tank commander, peering through compromised optics, was now less effective, his situational awareness severely degraded. This brief respite was all the accompanying anti-tank bazooka team needed. A well-aimed rocket streaked across the sand, striking the Panzer's side armor and sending it up in a plume of smoke. Word of the Scorpion's performance spread like wildfire through the ranks, quickly becoming a whispered legend. Yet, the brutal realities of desert warfare quickly exposed new challenges. The forced air cooling fans, while revolutionary, were susceptible to the incredibly fine, abrasive desert dust. Filters clogged, motors occasionally seized, and battery packs, while more resilient than initial prototypes, still struggled with the extreme heat and the demands of sustained combat. Maintenance crews, suddenly faced with electromechanical components on a weapon that was once purely mechanical, scrambled to adapt. Dr. Finch, receiving field reports, immediately dispatched a small team of engineers to North Africa, establishing mobile workshops to troubleshoot and refine the Scorpion under actual combat conditions. This on-the-ground adaptation was crucial, leading to quick design tweaks, improved sealing for the fan assembly, and more robust battery charging protocols. The Germans, initially bewildered by the sudden increase in sustained Allied machine gun fire and the unexpected harassment of their armor, began to take notice. Intercepted radio communications spoke of a new, terrifying American machine gun that could outshoot the MG42 and blind our panzers. Rommel himself, ever attentive to battlefield innovations, ordered intelligence reports compiled on this mysterious new weapon. German tank commanders, who had grown accustomed to treating Allied medium machine guns as mere irritants, now reported instances of damaged optics, shredded external equipment, and even track damage from concentrated fire. The psychological impact was profound. No longer could a panzer simply roll forward with impunity, shrugging off small arms fire. The Scorpion, while not a tank killer, was a definite tank threat, forcing crews to be more cautious, to button up more frequently, and to expose themselves less. This disruption, however subtle, was exactly what Allied strategists had hoped for. However, the wider adoption of the Scorpion faced its own battles within the Allied command structure. There was resistance from traditionalists, who viewed the modifications as overly complex and unnecessary. Why bother with this Frankenstein's monster when we could just field more anti-tank guns? Some senior officers argued, their skepticism fueled by the logistical headaches of supporting a specialized weapon. Production ramp-up was slow, limited by the specialized components and the need for precision manufacturing of the API rounds. Dr. Finch's team fought tirelessly against the bureaucratic inertia, presenting compelling combat reports and revised cost-benefit analyses. They argued that the Scorpion wasn't a replacement for anti-tank weapons, but a vital force multiplier, bridging the gap between infantry fire support and dedicated anti-tank assets. It offered infantry units an organic, immediate response to threats that previously required calling in heavy support. The sheer momentum of its battlefield success, however, was slowly beginning to win over even the most stubborn critics. The demand from frontline units, who had witnessed its power firsthand, became increasingly vocal, creating an undeniable pressure on the supply chain. The Scorpion was proving its worth in the crucible of El Alamein, but its journey from a clandestine project to a widespread battlefield asset was far from over. The German High Command, now aware of this new threat, was undoubtedly working on countermeasures, ensuring that the technological arms race in the desert would continue unabated. The engineering team dispatched by Dr. Finch arrived in North Africa, a stark contrast to their sterile stateside laboratories. They immersed themselves in the crucible of combat, working side by side with frontline mechanics and gunners. The fine, pervasive desert dust, a silent saboteur, remained their primary antagonist. Finch's engineers, led by a pragmatic young prodigy named Eleanor Vance, who possessed an uncanny knack for field improvisation, immediately began refining the cooling system. They developed advanced, self-cleaning air filters for the fan assembly, utilizing a vibratory mechanism powered by the weapon's recoil. Battery packs were redesigned with improved thermal insulation and more robust casings, and new, hand-cranked emergency generators were introduced, allowing units to recharge in the field even without vehicle power. These rapid, on-the-spot modifications, born out of necessity and validated by immediate combat testing, dramatically improved the Scorpion's reliability in the brutal desert environment. As the Battle of El Alamein raged, the Scorpion, M1919s, though still relatively few in number, began to make an outsized impact. Their sustained rate of fire allowed Allied infantry to finally match, and often suppress, the dreaded MG42s. The high-pitched buzz of the German buzzsaw was increasingly met by the deeper, more sustained roar of the Scorpion, often forcing German gun teams to withdraw or be neutralized. The psychological advantage that the MG42 had long held began to erode. But it was against German armor that the Scorpion truly shone. Tank commanders, once confident in their steel cocoons, now found their periscopes shattered, their track links damaged, and their external fuel drums ignited by concentrated bursts of API rounds. The blinding flashes and smoke from the incendiary components created chaos within the tanks, forcing crews to button up, reducing their visibility and situational awareness to dangerous levels. This disruption, often lasting only crucial seconds, was enough for Allied anti-tank teams, previously struggling to get into position, to deliver the killing blow. One particular incident became legendary. During a desperate German counterattack near Tel El Isa, a spearhead of Panzer IIIs and IVs, supported by grenadiers, threatened to break through an exposed British position. Two Scorpion teams, positioned on a rocky outcrop, opened fire. Their sustained torrent of API rounds hammered the lead panzers. One Panzer IV had its commander's cupola repeatedly struck, its vision block shattered, and its external radio antenna severed. The tank, effectively blinded, veered sharply, exposing its thinner side armor to a waiting 6-pounder anti-tank gun, which quickly dispatched it. The 2nd Panzer, attempting to flank, had its track links pummeled until one snapped, immobilizing it and making it easy prey for infantry with Piats. This was not the work of dedicated anti-tank weapons, but of infantry machine guns, a scenario Rommel's forces had never anticipated. The Scorpion didn't destroy tanks, but it made them vulnerable, turning seemingly invincible steel behemoths into hesitant, disoriented targets. The German response, while swift, was ultimately reactive. Rommel's intelligence officers quickly identified the new American weapon as a primary threat. Initial countermeasures included reinforcing periscopes with thicker glass and adding small, angled steel plates around vulnerable components like exhaust ports and external fuel tanks. Panzer crews were instructed to minimize exposure, button up sooner, and rely more heavily on accompanying infantry for close-range protection. However, these adaptations were often hasty and incomplete, and the Scorpions' sustained fire and accuracy still found ways to exploit weaknesses. The psychological impact remained. German tank crews, once masters of the desert, now had to contend with the constant threat of being blinded or immobilized by what they once considered mere infantry fire. The Scorpion had effectively shifted the tactical balance, making every tank advance a more dangerous and uncertain proposition. The success at El Alamein and the subsequent Allied drive across North Africa provided irrefutable proof of the Scorpion's value. Combat reports, filled with testimonials from grateful infantrymen and tank destroyers, flooded back to Washington. The bureaucratic resistance, once a formidable barrier, crumbled under the weight of battlefield evidence. Production orders for the modified M1919s and their specialized API ammunition were drastically increased, with new factories brought online. Dr. Finch, once dismissed as an eccentric dreamer, was now hailed as a visionary. His team, including Eleanor Vance, received commendations, though Finch himself remained largely in the shadows, preferring the quiet satisfaction of seeing his impossible ideas prove their worth. By the time the Axis forces in North Africa surrendered in May 1943, the Scorpion M1919 had become an integral, though still specialized, part of the Allied arsenal. It had proven that an existing weapon, through ingenious modification, could be transformed to meet unforeseen challenges. While it never fully replaced the need for dedicated anti-tank weapons, it provided infantry with an unprecedented organic capability, filling a critical gap in fire support. The principles pioneered by Finch's team, particularly the forced air cooling and the development of specialized multi-role ammunition, influenced subsequent weapon designs. The concept of modular weapon systems, adaptable to different combat roles through field modifications, gained significant traction. Dr. Alastair Finch, after the North African campaign, continued his work, though his focus shifted. He advised on the development of heavier machine guns and anti-material rifles, always pushing the boundaries of what was considered possible. He remained a quiet, almost reclusive figure, more comfortable with schematics and prototypes than with public acclaim. Eleanor Vance, inspired by Finch's audacity and her own experiences in the field, went on to lead significant ordnance projects, becoming a respected figure in military engineering. The Scorpion M1919, while a pivotal instrument in the North African theater, did not become the universal standard M1919 for the remainder of the war. Its specialized nature, higher production cost, and the continued logistical demands of its unique components meant it was primarily deployed to units facing the most challenging armored threats, or where its sustained suppressive fire was deemed critical. As the war progressed and other, purpose-built heavy machine guns and anti-tank weapons became more readily available, the initial urgency for the Scorpion lessened. However, its legacy was profound. It had demonstrated the power of innovation under pressure, proving that ingenuity could overcome seemingly insurmountable technological gaps. It had given the Allied soldier a crucial edge when it was most desperately needed, helping to turn the tide against Rommel's formidable Afrika Korps. That impossible, tweak to the venerable Browning M1919 had not only transformed U.S. defense at El Alamein, but had also redefined what was possible on the battlefield, forging a path for future innovation in the relentless crucible of World War II. The whispers of the Scorpion continued in the veteran ranks, a testament to the ingenuity that armed them to face impossible odds, and a silent tribute to the men and women who dared to dream beyond the limits of conventional warfare.